Today we will speak about factorization. The first technique we'll speak about it is the greatest common factor. Okay. So what is the greatest common factor here? If we have 10x cubed plus 6x, we could see here there is a common factor which is, for example, here this can be written as 2 times 3 and here is 2 times 5. Okay, and x again is a common factor. So 2 and x is common factors here. What is left from the first term is the 5. Okay, and we took already 1x from here, so we'll get the x squared. If we multiply, get the x cubed. And what is left from there is, you see, 2 already has gone. So what is left is the 3 and no x. If we multiply to check, this is 2x times 3, which we will get the 6x. Okay, so this is what we call a factorization. Okay. The second technique we'll talk about is factoring a trinomial. Okay. If we have x squared minus 5x minus 14 here. Okay. Now we will go for the cross products to factor this term. And the first things to do is to factor the x squared. Here x squared can be written as x times x, which is x squared. Then we will look for two numbers. If we multiply them, we will get the 14 or the negative 14. And if we add them, we'll get negative 5. Okay. If we multiply 14 times 1, that's negative 14. We can do it. But either if we add them, we'll get negative 13 or positive 13. So that will not work. So we can get another factorization, which is like 7 times 2. Now, if the negative is over 2, then the addition, the multiplication, of course, is negative 14. But the addition will be plus 5. However, we get negative 5. So what we need is modify this, and now we get negative 5. So the first factor is x minus 7, and the second factor is x plus 2. This is trinomials. Just one note here, we wish to say that this trinomial sometimes cannot be factored. You can check if it can be factored or not by using the discriminant, which is b squared minus 4ac. Okay, you still remember the coefficient here is a, and this coefficient is b, and this is the c. Okay, so if we apply it here, we will get b squared, which is 25 minus 4 times 1 times negative 14 here. Okay, and if I multiply 14 times 4, I'll get 16 here, and this is 4 and 1, which is 56. So 25 plus 56, which is 6 and 5 is 1, and here is 8. You see here what you get is a perfect square. It means that you can factor your trinomials here. If it's not perfect square, then you cannot factor it. Okay. The third topic is factoring two perfect or difference of two perfect squares. Two perfect squares, okay? Which is like you have a square minus b square. So the first number has a square and the second number has a square. And this will goes to a minus b times a plus b. Okay. So let's say that we have x squared minus 25. The first number is a perfect square, and the second number we can write it just 5 squared. So we can factor it as x minus 5 times x plus 5. Okay. So that is this is what we call difference of two perfect squares. Okay, we could have also, like another example is 49 x squared minus 144. Okay, the first term is 7x whole square, and the second one is 12 squared. Okay, this is will goes to 7x minus 12 times 7x plus 12. So this is what we call factoring of different two perfect squares. Okay. The third topic is if you have cubes, whether they are addition or subtraction or difference between two perfect cubes. Like we have here is a cube plus b cube. Okay, so let's say a plus b, you'll get the same sign without the cube. And then you will get a square, you will square the first term, then you will multiply the first times the second. And you see, here you have a positive, here you have a positive, then you will go for negative. And finally, you will just square the last term. You will get b squared. Okay. Now, if you have also different of two cubes, it is almost the same. You will take the cubes out, you get a minus b. Then you will square the first term, you get a squared. And you will get plus here, you will multiply a times b, the first times the second, and finally plus b squared here. Okay. Let me take example. We have 8a cubed plus 27b cubed. This can be written as 2a cubed. This is perfect cube. And this is again 3b cubed. Okay. Now you can write 2a plus 3b without any cubes. And the second bracket is very easy. You will take the first term and you will square it. So you'll get 4a squared. Okay. At the end, you may square the second term, you get 9b squared. In the middle, you just multiply the first times the second. So 2 times 3, which is 6a times b. So this is 6a times b, or ab. This is what we call the cubes here. Okay. The last topic is factoring by grouping. Okay. So assume we have b squared plus p minus q squared. Okay, this is what we wish to factor here. Let me take p squared with the q squared. So I'll get p squared minus q squared. And these group them together, you get p minus q. So the first group is here, the second group is here. Now we can factor this as a perfect of two squares, which is p minus q times p plus q plus. And here is p minus q, the second group. Now you could see this is a common factor. So I'll say p minus q outside. What is left from the first term is just p plus q. And the second term is just plus 1. So when you multiply p minus q times 1, you will get p minus q here. So this is we call factoring by grouping. Okay, let me take some examples, some exercises here. Assume I wish to factor x to power 2n plus 2 plus 5 to power x to power 2n plus 1 times 6x to power 2n. Okay. As you can see here, we have x to power 2n is a common factor. So we can take x to power 2n as common factor. And what is left is x squared. If you multiply this term times this term, you will just add the exponents here. So you'll get 2n plus 2. And here is 5 times x to power 1. So if you multiply, you get 2n plus 1. And here is plus 6. Okay, now this is a trinomial. You can just go for x times x here, and this is just 2 times 3. If you multiply these two numbers, you will get 6. If you add 2 and 3, you will get the 5. So this is x to the power 2n. First bracket is x plus 2. The last bracket is x plus 3. Okay. Okay, so assume I have also x plus 5 times x plus 3 plus x plus 5 times x plus 1 here. Okay. Now, I could see that x plus 5 is there and there. We can take it as a common factor. What is left? So this is by grouping. What is left is x plus 3. Sorry, but this is just a common factor. Here is x plus 3, and here we have x plus 1. Okay. So here we drop this term and we drop this term, so we'll get x plus 3 and x plus 1. Okay. Now we can simplify here, so we'll get 2x and 3 plus 1, which is 4. Last step is we can see that the 2 here is a common factor. So if we take 2 common factor, we'll get x plus 5, and here will be x plus 2. You can multiply the 2 times x, you get 2x. 2 times 2, you'll get the 4. Let me go for 6x squared minus 5x minus 4. This seems to be a little bit trinomial, but it could be hard. So I'll go for the discriminant b squared minus 4ac. So this is my a, this is my b, the coefficients, and this is my c. Now, b is 25 minus 4 times 6 times the c, which is negative 4. And if I use a calculator, I'll get this is equals to 1 to 1. So fortunately, this can be factored. Okay, what I'm going to do is I'll try to factor the 6. I may write it as 3x times 2x. You may try 6 times 1, 6x times 1x. Okay, and here I could try also negative 1 and negative, okay, here is, I could try negative 1, so this is plus 4, so here we have plus 4, okay. So if I multiply negative 1 times negative 4, it's plus 4, and if I multiply here 3 times 2, I'll get the 6x squared, and if I multiply in the middle, I'll get negative 12x. Okay. So this is negative 12x and negative 2, so I'm missing something here. So that's negative 2x. Okay. So what I'm missing here is the negative sign here is negative 4. Okay. And I'm also writing this is wrong number. This is 11, sorry. Okay. So this will be just positive. Okay. You may try it now. So that was a little bit confusing. Okay, but try it now. You'll get the factorization will be 3x plus 1 times 2x minus 4. Okay. So this is negative 12. Okay. Sorry, this will be 10x here, and this will be plus 2, so the total is 10x. Okay. So you may rearrange this again. Okay, if I have 50x a to power 4 minus 36, sorry, b squared. You could see that there is 2 is a common factor, so I'll get 2 here. I'll get here 25 a to power 4 minus, here is just 6b, you could say whole square. Sorry. I need here is 72. Okay, so that's 72. So if I take 2 common factor, I'll get here 36b square. Okay. Now, here this is equals to 2 times 5a squared whole square. So when you square the 5, you get 25. If you square a square, you just multiply the exponents, I'll get 4. Minus, here is 6b whole square. So the first one is perfect square, and the second one is a perfect square. And that is goes to 2 times, okay, the first bracket is 5a square minus 6b. Second bracket will be just the addition between them, and that's plus 6b. Okay. This will be the last example. If I have here 3xy plus x, and here I have 9y plus 3. Okay. From here, by grouping, I can take x as common factor. So what is left is a 3y plus 1. I will group these together again. I'll take 3 common factor. I'll get 3y plus 1 here. Okay. Now, this can be taken as a common factor. So that is a 3y plus 1. And what is left is x and plus 3 there. So that is factoring by grouping. Okay. Since I made mistakes in the trinomial, I confuse you, I'll just repeat that with another example. So this is x squared plus 7x minus 18. Okay, I'll check if it can be factorized or no. Maybe this is very easy, so I'll go straight forward for factorization. So this will be just like x is here, and the 18, which is 9 and 2 will be 18, so I need the addition here. So one will be, here will be the negative. So if you add them, you get to plus 7. So this is x plus 9 and x minus 2. Sometimes I don't check the discriminant because it's very easy to factor the trinomials. Okay. Thank you for watching and see you again.